Hey, can everybody hear me? I'm assuming so. Monitor's working for a change, so I'm going to put this down. So, as some of you know, I've been setting up AUX on a Macintosh 2 CI. It's a little complicated because I don't have a network card for it yet, but I was able to set up a serial connection so I could do a terminal session from my PowerBook 520C over to the AUX machine using a serial connection. So that's up and running. And you can see it on my screen because it just so happens that I can capture the screen for the 520C from the external port, second monitor port. Just happens to work at 60 hertz, whatever. So the cheap adapters work. Let me see if I can show you the arrangement here pretty quick. So here I got my 520C, and here is the 2CI, and I'm not going to drop the monitor down because of all the arrangements here, but there's a cable running between them. There is a combination modem and printer port on the 520C, so you just connect a standard 8 DIN printer cable to it, and then on the back of the 2CI there's both a modem port and a printer port, and it's connected to the modem port. You do have to go through some configuration to get things to work. Because I don't have an Ethernet card on the 2CI, you have to disable Apple Talk, or it'll try to chat over that serial interface. And then there's some configuration you have to do with Getty and init, the initialization daemon. I can't remember what it's called. Anyway, long story short, I'll do another video on how to set all that up. If you go to my blog, and that's at Pragmatic Pizza. Oh gosh, I forgot the URL. Hang on a second. Let me bring that up. pragmaticpizza.blogspot.com. I have two posts on AUX there. One is on getting your 2CI set up and running using a Blue SCSI and a borrowed CD-ROM drive from another machine. And then the second post is about setting up a terminal using your SE or your Plus or PowerBook or some kind of 68K Mac that's got a serial interface. So if you care to look at that, I figured it was easier to blog it than to put it in a video. But there you are. So let's see. Let's switch over to here so you can see the screen. So hopefully that's clear enough for everybody to see it. So I have not worked in this version of Unix in 35 years. I certainly haven't worked with the C shell in that long. There are several shells that are available in AUX out of the box. You can have the classic C shell or corn shell. C shell is what I learned when I was in college. So I'm actually kind of going through one of the books that I had in college too that teaches you how to use the shell and stuff like that. And I'm also, but this is strictly about using the second edition of the C programming language by Brian Kernighan and Dennis Ritchie. And this was the, these are the guys that they created the C programming language. They essentially created Unix, so this is the holy grail for Unix programmers. Goes into, how the C language works and various things. But, I thought we'd just kind of go through the getting started section of the book and talk about, throw in some of the programs from it and see what happens. So I posted on Twitter the other day the example program I found in the AUX documentation didn't even include the standard I/O library. It was just the main function and a print hello world thing, and it ran. So there must be some assumptions about this environment for what's assumed to be included. The standard I/O library must be linked, automatically for you. Don't know any of the details yet. I'm just getting started on this, so some of the other things I plan to do is I'm going to get the bash shell. There's a version of it that works on here. There's also, an upgraded tar, various utilities. There was a group of programmers at NASA that used AUX, and they had a very active FTP site and information about it, and that's been archived. So plan on digging through that and doing some updates and upgrades, and I'll be posting probably blog posts mostly about that too. So let's... Oh, hi, 1-Bit Fever Dreams. Glad you could join. Not sure who else is here. That's the only comment I've got. So let's go ahead and get started with this programming and see where we go. So the classic program is Hello World, and we'll do that. Now, if I were doing this on my 2CI, you actually have OS 7.0.1 to work with, and they did a pretty decent job of integrating the graphical tools that you have in the Macintosh world with Unix. So you can actually use the text editor that comes with what is it, Teach Text? Yeah, that comes with the OS. Or you can use a text editor. That's a GUI editor they built especially for AUX. You can use the classic VI or ED. I cut my teeth using VI. I'm not an Emacs person. Don't get started on the Emacs versus VI thing. Never liked Emacs. I don't know why. Because I learned VI first. So since this is a terminal session and not a windowed, where I could run a GUI natively on, it's not an X11 session or something like that. I need a network card to be able to do that. I'm going to use the classic command line tools that I learned how to use when I was in college. So the editor is VI, and you put the file name after it that you want to edit. And if it doesn't exist, it'll create it. And you can see I'm running at a fairly slow baud rate. VI takes you into what is called command mode to start with. There's two modes, command and edit. So in command mode, you're running commands like saving and leaving VI, things like that. I know very few of the commands. There's like line deleting commands. I think DD deletes the line. Moving, you didn't use cursors initially, you used L, K, and stuff like that to move from up a line, down a line. And you went into insert mode by typing the letter I. Now, use the right keyboard here. So now we can type in include standard io.h. This is the standard C library for input-output. Okay. Some things are assumed in this version of C, like the return value for the main is assumed to be an int if you don't define it. So you really should be doing void main, but I'm not going to do that. So this is going to return an int, but we're not going to actually do that. Well, maybe I'll throw it in. Let's just do the... So printf is the parameterized print statement that you can use. It takes parameters and stuff. You use a double quote to start a string. String constants are something in C as opposed to string that you can manipulate, which is an array of characters. This isn't a lesson in C, okay? I have forgotten more than I remember. I haven't programmed directly in C. I did DOS programming when I first got out of college back in '89. And then I moved on from there to other languages. I think I worked in DOS in C for about 5 years. Anyway, recently getting back into it. I plan on doing a lot of Think C, probably version 6. I've been playing with 5, but Eric Helgeson intends to start a group where we can do I'm calling it a code along, where we work through the examples of a C programming book and get her feet wet with doing that for Macintosh programming. So I'll look forward to doing that. Anyway, so printf, hello world, exclamation point. In C, you do a new line character. Now I got to remember which way it goes because it's been a while. It's a backslash. So slash is the escape character. Backslash n means new line. And then you close it with the brace. The C programming language does not require formatting like, say you're in Python. How you space things and the indentation between lines is very important in Python. In C, you use curly braces to indicate a block of code. So you could actually do this as a single line program. In fact, let's do that for the first thing. I'm sorry, I'm clicking on the wrong screen here. So let's see if the arrow keys work in this. Thank goodness they do. Can I do a delete? Nope. I probably just messed this program up. So let's just leave it alone. I'm just going to save it. All right. Escape takes you into out of insert mode into command mode. You do a colon W and then quit. Yep. Cat is catalog. I probably messed up the text of this program. Nope, actually it's fine. All right. Hey, who else we got? Retro Techie. Hey. Yeah, backslash. Yep. Forward slash. Totally different. Okay, so we've got a program. It's not a big program. There's not much to it. The compiler that comes with AUX. Oh, this is AUX version 3.1. So I started with 3.0.1, I think, and then ran an update, and then there was another update after that to get to maybe it's 3.1.1. Can't remember off the top of my head. Doesn't matter. Anyway, there's several compilers. You have a Fortran compiler that comes with it. There is a C compiler. There's a couple other language tools. You also get my favorites, Lex, which is the lexical analyzer you can use to build a computer language. There is Yak, which is yet another compiler that is used to create compilers. It's a compiler for compilers. Awk, AWX, which is, I don't remember what it stands for, probably awkward. It's either the initials of the guy that developed it or part of his last name. I don't remember now. And that's for manipulating text files. Sed for searching through text files and editing them. It's a searchable editor, I think. Gosh, I haven't used any of these tools in forever, so that'll be an exploration. Anyway, cc.c is your program, and then if you want to output, it defaults to ls. Okay, it did not do it because I used the backspace on it. I got to figure out the shell on this. If you just do CC. Here we go. A.out is the default output for the compiler. .c minus O, hello. Minus O is the option to tell so that you can name the output file. And there it is. What is it? No, it's not A. What's the ls command for looking at executables? Gosh, I don't remember. Anyway, there's an ls modifier command where it puts an asterisk at the end of any executable file so that you know it's executable. Don't remember what it is. Like I said, I've forgotten more than I remember. So, anyway, so the program's there. Hello world. There you go. The classic, very first programming assignment every student gets is hello world. All right. So, let's do something more interesting. Let's tack a return on this. Let's see, insert, go up, tab. Okay, semicolon is termination for a statement. So, like I said before, you can, white space is almost irrelevant. You could run all of this together without any spaces in between it, except of course your string, and it would work because it uses the curly braces, the parentheses, the semicolons as actual markers for the end of a statement, you know, that kind of thing. So in fact, we'll go ahead and create one that's like that just so I can show it. I believe the include directive has to be on its own line though, if I remember right. Alright, so let's escape. I didn't escape. Oh, it helps if you type the right command. Write and quit. I'm not used to the Macintosh keyboards yet. The slash and stuff are in a different place than I'm used to. Make a program to take over the world. I am not building Skynet. Somebody else can do that. Besides, I don't have the special chip. Okay, so let's do a new hello. Well, let's run this anyway. cc hello .c minus O hello, compiled, replaced it. You notice there's no change in the output. You could redirect the output to a file and look at. Nah, I'm not going to mess with it. Besides an integer output, you'd have to convert it. I don't know. I'm sure there's commands where I could see it, but again, been 35 years since I touched Unix, so don't remember. So let's do one line .c. So we're going to insert, include, standard io.h, main, printf, hello world, backslash character, return 0. Okay, everybody agree that's the same? as what I did before. I think so. So now if we escape, right and quick, one line.c, boy, I'm just messing this up. That's gonna, like, fatal, I can't open the file. It's because I did backspaces. Ah. There. I really need to learn how to use the shell so that I can do this right. I'm sure there's changes I have to make to it so I can enable backspace or something. Okay, so we should have a one line, same output, so white space doesn't matter. It does make for very unreadable code, though. Try that in Python. For the record, I know Python. I don't like Python. I also learned Pascal in college. I hate Pascal. I really like C. But that's me. I'm biased. Let's see what else we can do here. So, now, here's another thing. The next example does 3 printf statements. So let's just hello 2.c. So if we do this, printf hello space printf, Pascal forces to declare so many things that I'm ready to design. Yeah, design on the fly. I hate string handling in Pascal. Having a fixed length to a string, just the library that's built into Pascal for string handling drives me nuts. In C, a string is a string. A string is a character array, and you put a null byte at the end of the character array to indicate the end of the string. In Pascal, it's implemented with a length character, 0 to 255, 254. Yeah, 255. Sorry. That single character in the front, and then what follows it is the string. So you're not scanning for the end of the string. In C, if you want to manipulate a string and you want to know where the end is, you have to find the null byte. So you have to look through the array, right? Not as quick an operation, granted. In Pascal, you read the first byte, it tells you how long the string is, and then you know where the end of the string is. It also means that that first byte, your string can only be 255 characters long. Who the hell uses a 255 character length for a string? I know there's string libraries and stuff like that you get, but why do that in the language to start with? I don't know. Pascal's a teaching language. It was never really meant at first to be a language used to do production work. That's not what it was intended for originally. Basic, same kind of thing. It was intended as a teaching language. C was not a teaching language. It was it's what came out of Unix, and Unix is the tightest implementation, little programs that do things that you wire together, kind of an operating system. One of the principles of Unix was that at first it was fairly small, and you could actually understand the operating system code. Of course, it grew from there, but that was the intent behind it. At least that's what I learned when I learned about it. And the C programming language is the same thing. It's a very terse language. It's as close to the metal as I guess, as you could get for a programming language, high-level programming language. And yeah, it's got issues like allocating memory, and you can do stomp all over the operating system if it's not a segmented architecture. The hardest problem to solve when I was writing in C in college, learning it, was causing a core dump and trying to figure out why, and it's because I had an uninitialized pointer somewhere to memory. Things like that. So it's a language that's not very forgiving of making coding mistakes. The modern languages have garbage collection and memory management and all this stuff built in, and by God, they need to have the architecture and the hardware and the speed of the CPU we've got today to be able to function, or they'd never fly. I like simple. So anyway, printf hello world, printf let's do the exclamation point and then the new line. Okay. Right, quit. Nice and slow terminal. Okay, so hello 2. cc hello 2.c minus O for output. Hello 2. Hello 2. Same output. So there's a lot of ways you can mess around with stuff in this. Anyway, that's it for that simple program. We'll see what's next in the book. They go on to section 1.2, variables and I can't speak today. Arithmetic expressions. So this is a program. What does it do? It prints a Fahrenheit to Celsius table. So I'm going to type that one in. So what are we calling this program? FAHR? No. I don't know. What do they call it? Now I got to find it. Oh, we're just going to call it FAHR. Whatever. So VI FAHR.C. Oh, insert. Include standard I/O. Okay, we're going to add a print or a comment. Print fair and height Celsius table. Main. I tell you, when I first started back into VI, Doom in one line at a time. Yeah. Yes, I'm going to start with the basic stuff. In about 10 years, we'll write Doom. Yeah, I heard Doom is actually pretty well written code. That's one of the reasons why it's so portable. They worked really hard at making it that way. So, why aren't you programming in BASIC? Because I'm not using my TI 99.4a to do this. That's why I'm not programming in BASIC. Hey, Garth. Where was I? Oh yeah, main. Float. So that's a data type for floating numbers. F-O-A-H-R. Celsius. When you declare variables, you can separate them with commas so they don't all have to have their own line. Lower equals 0, upper equals 300. So that's a lower limit of the temperature scale and the upper limit of the scale. I guess we can't do anything below 0 and over 300. Step equals 20. So that's the step size. FAHR equals lower. So we're going to start with the lower temperature. Oops. Why? Yes, Garth, why are you not programming in BASIC? I never really learned how to properly code, so I have to make jokes to make up for my inadequacies. Then we're all comedians, because I was saying earlier in the stream, I have forgotten way more than I remember, and I'm not kidding. This is like 35-year-old environment for me. It's been that long since I touched it, at least 35. I went right into DOS C programming after I got out of college. I didn't touch Unix after that. So Garth, you want to get your Apple IIc set up handy so I can do some basic programming again. That's great. You know, that was the first programming language I learned. I taught myself how to program in BASIC on a TI 99.4a. Other than the fact that as soon as I think at community college, I did one course in BASIC before I went on to either Pascal or it must have been Pascal, or was it C? I don't remember. You know, BASIC was where I started, so I could play around with it a little bit. I don't like Go2. I use Go subs if I can. Although Go2 is appropriate in certain circumstances. If you're doing a state engine and you need to jump between different code areas to manage state, it's a really useful command for that. But it does make the code kind of hard to read. Okay, where were we? I was doing a while statement. So while... Now, some people do this. There is several styles of C. K and RC, Kernighan and Ritchie, they like to do the brace right after the function name and then line up the brace with the start of the function for the end brace. I learned habits in Pascal when I was doing it. I like to line the braces up with the function because then I could always see exactly where the function begins and ends, and it helps me with indentation. It's a personal thing. I never liked places that insisted you write in a certain way. There's filters like lint that you can use that'll reformat it to some standard. If somebody's going to be that anally retentive about how the software looks for the library, run it through a linter of some kind. And stop being an ass when it comes to programming styles. But that's me. Your mileage may vary. Okay, so we're going to check while FAHR is less than or equal to, that's a plus, equal to upper. So we're going to run through the table. That's what the while statement's for. Could use a for statement to do this. We're going to do the conversion from Fahrenheit to Celsius, 5.0 divided by 9.0. So we're doing floating point arithmetic. And I just did something a little different. Normally I separate the operator from the operands, and I didn't do it for the division. I did it for the subtraction. Sloppy me. Not going to fix it. Printf. Okay, here's printf. This is going to take a floating point in the %3.0. I believe is no decimal, no fractional part after the decimal, and 3 characters for the integer value. I could be wrong. Can't remember. Oops. 6.1f. And then we're going to do a new line. So you can see the way this printf function works is it takes parameters. The first parameter is a string that describes what's going to go into it. So we're going to do a floating point number, a space, and a floating point number followed by a new line. And then for each one of the percent parameters inside the string, you have to give the value that you want to go there. Okay, so we want now to do, otherwise we'll do an infinite loop. Okay. Now you can do a plus equals, and so you could do FAHR plus equals step, and it would increment FAHR by step. This is keeping it simple in this example. Okay, so we close the while, and we close the program. So, escape. Aren't you supposed to do 0.0f and 300f since they are floats during assignment? I don't know. This is straight out of KNR, so we'll see what happens. Yeah, Ron broke YouTube and caused it's probably caused a disturbance in the space-time continuum, and YouTube is going to be sucked into a void and no longer exist because he posted an hour-long video of a program that he runs, and it's a very simple program, and it's cool, and you should watch the entire hour. There's a special thing that happens at the end, right, Ron? Got to get those watch times in, right? All right, so we got the program. Just gonna list and make sure it actually saved it. Okay, so we're going to compile it. cc fahr.c -o fa8. I'm just going to leave it far. What the heck? So we should have an FAR executable. All right, FAR. Okay. So since the step was an integer value, it was just going to step 20. The format of the output didn't need to include the fractional part. So let's modify the program. And let's mess around with it a little bit. Well, for one thing, I don't like the way the comments formatted. Insert. Tab. So we'll leave it like that. Let's do a step that's different. So let's do 20.5. Okay. Catch up with the chat. Yeah, Apple 4 forever, right? It was originally 12 hours, but the 12-hour version wouldn't upload properly. Cool. Your temperature calculation, make sure it becomes a float since there were numbers with the decimal part interacting with your numbers. Yeah, that you're right. That should be, well, step is a float, right? So that 20 should have been 20.0. Maybe that's assumed with the C compiler. It does a little bit of typecasting. I don't know. Seems like that would give an error. Or maybe if you do the compiler with the right settings, it would give you a warning for it. Again, it's been like forever since I've done this this kind of C programming in this environment. Well, I never did AUX. It was VAX, mini computer, and before that a Xenix computer running on a Motorola 68020 chip, because I learned assembly the same time I learned C, which is great for learning C, because if you it's great for learning assembly and C. You compile your C program and you look at the output that's in assembly and you're like, oh, that's how a for loop is implemented. Oh, that's how you do a for loop in assembly. You know. But I only had one class that had assembly in it. The only other time I touched assembly was senior level class. We had to write a compiler in a programming language from scratch, and we decided to do 8088 assembly because there was a guy in our group that knew how to do it. So I can catch up on the chat here. Blah blah blah. C knows how to mix ints and floats during an equation. Yeah, it depends on the C compiler though. There are implementations of C. I think small c. It was a x86 version of C that would fit within, you could run it in DOS without extended memory or anything. It's been a long time since I saw it. And it was like a learning environment for C. You could actually recompile the source in itself. It bootstrapped. So you could mess around with the language and then recompile it. But I ran into a guy who really wanted to learn how to do that kind of stuff, and I gave him the disk and book that came with it because I didn't feel like I needed it. I wish I had hung on to it. I'd have it today, but I don't. Someone's cleaning up a Genesis 6 button controller. The former owner loved chicken wings covered in sauce. Yeah, that sounds really chunky. No, I wouldn't touch that. So, %3.0f will not display any decimal. Sol's correct. Okay. Yeah, I'm going to try 3.3. So that'd be 3 decimals, or 3 positions after the decimal. I'm also going to clean up this because this really annoys me. I know it doesn't make any difference. However, because... So we want 3, not 30. Oh. Backspace does not work properly. I'm not sure how to get this to work right. What the heck? Let's just leave it that way. Oh, I know. Is it X for deleting? Ha! I remembered. Yes, this really is a live stream. So I'm gonna show you exactly what I'm doing here. I got to turn the tablet back on because it decided to go to sleep. There's my 2CI running AUX. So, my kingdom for a mouse. I've got like 3 keyboards here and 3 mice. About Command Shell. Command Shell v3. So yes, this is AUX. About this Macintosh. You'll see, well, maybe you can't see because it's too far away. And it's still going to be too far away. Anyway, Command Shell's running in 576K. And then you got the system software. So, yes, this is running AUX. I'm probably going to bonk my head with this now. Anyway. And then I have a serial terminal connection running between, over a printer cable, between the modem port on the 2CI and the combination modem and printer port on my 520C, because I can capture the output of the 520C and put it up here, because it just happens to be a run at 60 hertz cycle, and my cheap HDMI VGA to HDMI works with it, so that's why it's the convoluted setup. But let's get back to the, because I've got a HDMI capture card in the PC, so I'm able to grab the output and show it. So it's kind of a roundabout way. I do not have a network card for this 2CI, and AUX is pickier than all get out with network cards. So I'm probably going to have to drop quite a bit to buy what I need. I'm hoping I can find one at VCF Midwest. I'm going to be going there. So if you happen to have a card and want to sell it for less than gold, I'd be interested. Anyway. Mr. Fahrenheit, you really host all my favorite content. HyperCard and AUX. Yeah. HyperCard's a passion of mine, but I was a C programmer right out of college, so that's also a passion. And I really need to spread out that HyperCard stuff. It's going to take me forever to get through all the material, and I'm afraid that if I didn't do other content, I would fall asleep doing it and never finish. So try to pick up a cheap, a Quadra 650. Yeah, that would be one way of doing it. What's the model number of the network card? Here, I can put it in the chat. Maybe. I've got notes for what I need. But I got to find it. Hang on. There is a website with lots of helpful information about AUX that has a list of compatible cards. And now I have to find it. Oh, wait a minute. I think I posted it in chat, didn't I? On Twitter? If I can find my... Okay. Bear with me a second here. That's not it. Yes, it is better if you can get a Macintosh with the built-in Ethernet on the logic board, because it's compatible if it's an AUX compatible machine. So oh crud, I'm not sure where I put it. Maybe I should look under tweets and replies. Anyway, there's like a half dozen cards that'll work, that are known to work. Here we go. Right keyboard. Get back to the chat. Pardon me. Paste as plain text. There you go. It's in the chat. It's an Apple Ethernet card, a 3COM Ethernet NB card, a Sante MacCon card, or a StarNet card, or a MacCon MC3 NB card. That was what was listed at, let me clean that up because it's a mess. That was what was listed as known working. Oh crap. Anyway, there's the list. If you go to, what is it, Penelope? Yeah, Penelope.com. And the hardware tab, and you scroll down, it tells you, which hard drive and memory requirements you need for it, which of the few CD-ROM drives work. I just happen to be lucky. I have an Apple 300, which is a Sony CD-ROM. I can't even remember the number on it anyway. It happened to be one that worked, and even that was a little problematic getting it to load. If you had it's one of those cartridge or caddy CD-ROM drives, and if you drop the CD in there and then boot the boot floppy for the installer, it doesn't recognize it. You have to leave it out, wait until it's asking, it tells you it can't find the CD, insert the caddy, and then start hitting the try again button until it happens to hit just the right time to catch it. If you wait too long and only hit, try again once, it'll miss it. So, anyway. Yeah, Penelope is the site. Let me grab that and drop it in the chat. So, very good site. There are several sites across the web that have stuff. There's a copy of, I forget the guy's name, from NASA that had all the stuff, and they had a very active FTP site and stuff. You can get pre-compiled binaries for, upgrading, the bash shell and things like that. And that's what I plan on doing. Yeah, alternative media. That'd be great. I did try, and I saw those posts about doing the magneto-optical. Oh, a jazz would be cool. I did try to do something with the Blue SCSI. There's beta support for mounting toast or ISO images on a Blue SCSI. Unfortunately, it's hard-coded what kind of. Yeah, Jugabox is the archive. So that's got a lot of great content in it. Unfortunately, the type of CD-ROM drive that it emulates is not a compatible drive. I don't even know if it would have worked if you could fake it and say it was a different kind of drive. AUX is very tied to the hardware, and it's hard to fake it. But if you could fake anything, I'm thinking if they... maybe in a later version of that toast support or ISO support for images, if they allowed you to set the version string for what drive it is or whatever it is that AUX is looking for, it's on the SCSI bus, so in theory you could fake it. I was able to get, because my floppy drive is a little flaky in this, or the image that I had was flaky, it wouldn't boot all the way. I was able to use a small hard drive image on the Blue SCSI, put the install floppy on it, made it the first SCSI device it would find, so it was 6, and blessed it by moving the system folder in and out, And that worked. I didn't have to use a floppy for the installer. I was able to boot from that and then have it work. But I still needed the CD-ROM. Yeah, see you, Retro Techie. Thanks for dropping in. But I did do a blog post where I described how I did it with my hardware and the limitations I was running into for what I had. For example, my SCSI cable. I only had one SCSI cable. I couldn't hang two devices, so I ended up putting the blue SCSI on my external on the back of the 2CI, and then putting the CD drive on the internal SCSI, and that worked, fortunately. Anyway, you want to read the details, it's in my blog post. So you did a DD of the AUX ISO file over to a Jazz cartridge and then replace the Apple CD driver on the disk. Oh. Nice. That's above my pay grade. What I'd love to see is have the blue SCSI get to a point where it can support all of these things, because it'd be really nice to be able to do that. I wanted the experience of installing AUX from scratch using the media. The Shoebill build that's available worked just fine. I was able to just drop that on a blue SCSI and boot from it, and it was fine. But I'm kind of like, ooh, I want to, when I installed 7.6.1 on my PowerBook, I actually made the 17 floppy disks you need to install it, and did it the hard way, just so I could do it. It's what I used to do. So I'm a glutton for punishment. Anyway, so can your 2CX support long? It's a 2CI. I'm not sure how long new bus cards get, frankly. It's not a very long box. I believe it does have to have an FPU. In fact, there's a short, if you look at Penelope, there's a very short list of machines that will run AUX. So, to quickly look at Penelope, they've got a nice chart. You can run it on a SE30. It's going to be slow, but you can run it on an SE30. You can do a Mac 2, a Mac 2X, a CX, a CI, SE30, a 2FX, which there's a comment here that out of the older Macs, it's probably the fastest one. 2SI, a Quadra 700, 900, 950, 610, 650, 610, 650. Why is Centrus 650 and Centrus 610? Sorry, and up to a Quadra 800. Of course, I'd love to get a Quadra 700 for the aesthetic, but then again, everybody else in the world likes the 700. Hey, Dave. The chart on the website isn't really accessible to... No, it's poorly designed for that. You're right. But it is a limited number of machines, and you can't just set the Gestalt and fake it. They did get it working in an emulator, though. So you can do that if you want to play around with it. Yeah, I get it. If you're colorblind, it makes it a little difficult to see. It's just shades of gray, right? Or it obliterates it and you can't tell the difference. And the chart that's going across there is for which version of AUX. I'm not interested in running the older versions. I'm not sure if there's any advantage to it or not. So, there's other people that have messed with that stuff more than me that could answer that. Did it get less capable in later versions? Did they make compromises or something? I don't know. I'm working under the assumption that the latest version is the best. but that website, yeah, it switches between green and red, so it would be difficult. A Mac 2 can run all versions. When you get up to the Quadra 610, 650, 800, or the Sentra 610 and 650, you can only do 3.0.1 and up. But all of them, all the compatible machines will run 3.1.1. So there is that. Let's see. Okay, so I think we've modified this program. We can give it a try and see what happens. So let me get the right mouse, and I believe I'm still in the editor, so escape. Oops. I tried to quit twice. Okay. So let's compile. C minus O FAHR. So now we have 3 decimal places, or 3 numbers after the decimal. Yay. Let's see what else we've got for programs here. So the book goes on to tell you what each line of the code does and why. For example, it goes into the parameters, different data types that you can do in a printf statement. You know, like decimal integer, floating point, and then the formatting for it. Goes into what the for statement does. So let's modify this so that it does a for loop instead of a while. So instead of doing this while, we don't have to. The for loop initializes the value. It's got 3 sections in it. It does a test to see whether or not you're done. What else? So the initial value, a test to see whether it should continue or not, and then a third expression that you could use to increment or decrement or whatever. So it really just evaluates 3 expressions, and it expects a true or false statement for the evaluation equation. I believe in this version of C, 0 is false and not 0 is true. Don't quote me on it. I'm not sure if that's correct. You know, different C compilers have different standards. Some of them true is 1. Sometimes true is -1. Depends on the implementation. Sometimes anything that's not 0. So you can get into shenanigans trying to do stuff. I don't remember what the K and R value is. Okay, Kelvin. You want me to change the formula to convert to Kelvin? You look it up and we'll change the code. So it would be 6,000 degrees Kelvin, or whatever it is. Isn't, what is 0 well, 0 in Kelvin is no molecular movement. It's the coldest temperature, right? I think 0 in Celsius is what, 3,000 degrees Kelvin or something ridiculous like that? I don't remember. Same scale, though, if I remember right. Kelvin is the same scale of, you know, each degree is the same as centigrade, Celsius. Maybe. I don't know. Physics was also 35 years ago. Anyway, so let's edit the statement. So we don't have to do that line. So I typed 2 D's in command mode to delete the line. We also don't want to do a while statement. I do want to insert here. So I'm going to do for FAHR equals 0. So this is our initial value. FAHR is less than or equal to 300 degrees. You see the semicolons to separate the statements. FAHR, I'm going to get fancy, plus equals. I don't know why the example doesn't use the step variable, but we're going to use it. Oh, yeah. And it also is not using the lower. Oh. Insert lower nope, I don't want to delete a whole line. That's what I get for typing weird characters. Now you know why VI can drive you crazy, because once you do something weird in command mode, you're not really sure where you're at. Okay. Alright. So less than or equal to upper, lower. I don't know if you guys have ever done this in BASIC. Have you ever done a loop, and then your condition is if a variable is equal to a number? And in BASIC, if you increment, say you do from, for I equals 1 to 100, and you increment I, sometimes if it's not doing integer arithmetic, you can end up with, so I is like 1, 2, 3, and you keep adding to it. I've seen BASIC programs that don't add correctly, or if you're doing a floating point in BASIC, so you do, oh yeah, this is it, for I equals 1.0 to 100.0 step 10.0 or something like that. So you're doing it in floating point, not integer. And what happens is it gets to 999.99999 and doesn't stop running because it doesn't equal 100 or 1,000 or whatever number you're trying to do. So that it'll just end up going forever. And I used to use that as an example when I was teaching programming languages, that you have to pay attention to what you're doing. Yeah, lower, upper, and step should be constants. You're right. What's the constant keyword? Is it con constant? Again, this is like the first chapter of Kernighan and Ritchie, so they haven't even gotten into what constants are yet. But you're right, they should be constants. They should be defined. Isn't that what it is? Pound define, and then you use uppercase to indicate a constant. Boy, I haven't programmed in this language forever. So let's go ahead and do that. Why not? Insert. Nope, I didn't want to insert. Shoot, not there. Nah, I messed it up. Okay. It's equals too, isn't it? I don't remember. Yeah, too much time in Java land. Yeah. There is no equals. You're right. There's no semicolon either at the end, because this is a pre-compiler directive. It's not actually part of the C language in that sense. Now I remember why I hate VI. Actually, why I really like better programming languages or editors. Everything was done in a text editor. You didn't have all this IntelliSense and the stuff that you have. So, insert 300. Oh, wow. That was weird. Let's just wipe out that line and start over. Must be a little bit of a communication glitch. Okay. That should really be 300.0. That should be 0.0. Oh. Alright. Oh, that's right. It moves the cursor back when you go to command mode, and you do that. This keyboard doesn't have the arrow keys in the spot where it's convenient. They're all in a row next to each other. It's because the nice keyboard's the same way. I guess I need some more keyboards. Never have enough keyboards. Oh. You would think in this version of VI they'd have some kind of indicator of whether you're in command mode or not, but they really wanted to keep the screen simple as hell. Yeah, I got a cheat sheet for VI somewhere, but I'm trying to do it off of memory because I'm a glutton for punishment, as I said. Alright. Plus equals step. Alright, so that should work, right? Lower, upper. Yep. Alright, so. Oh. We need to not increment this, because it's done for us in the third statement of the for loop. Let's increase the output on the table here. Must be painful watching me edit in VI. Oh my god, he pressed the wrong key again. Alright. I wanted the full experience, so I'm getting it. Alright. Remove that float lower, upper. Okay. Oh, yeah. Don't need it anymore, do I? VI FAHR, because we're really concerned about the amount of memory we're using. Good programming practice. Okay. In fact, you don't even need the variable Celsius. You could put the actual calculation into the printf statement, but that wouldn't be great form. You're wasting so much RAM, Eric. This is a tragedy. Yes. I have a whole whopping 20 megabytes of RAM in this 2CI. I think the minimum requirements for AUX is 8 megabytes. Yeah, I used DD to eliminate a line. I can remember a few VI commands, but not that many. Like X for deleting a character, DD for a line delete. That's probably it. K and L for up and down. Yeah, nice debugger somewhere. Eventually I want to dig through the debuggers. I was very much a stick a printf in and see where, if it gets there, kind of a debugger. I never did use the tools that were built into Unix in college. They didn't care if we learned that. In fact, I switched schools partway through college, and the school that I was in, computer science was part of the College of Engineering. And so they were very picky about learning all the things, and C was the primary programming language. I switched to another college to finish, and the programming, computer science program was in the Department of Mathematics, not engineering. So they were a lot more theoretical, and they were more heavily focused on the mathematical aspects of computer science, and big O notation and Turing engines and all that kind of stuff. Anyway, they didn't care so much about the programming, and in fact Pascal was the primary language for teaching there. But you could also program in C. They didn't have any problem with that, so I used C because that's what I liked. And there were a couple of professors there that were, they're like, "Oh yeah, I don't care how you figure it out." And one of the assignments, we had to do something that was interrupt driven, and if you're doing that kind of programming in C where you fork and you have another thread, a lot of the functions are not reentrant. So if you're trying to use printf and it gets interrupted, you can really screw up the output of your program, and eventually it'll just go off in the weeds and play with itself. And we did this thing where we had 4 quadrants on the screen, and you had to make it look like you had 4 programs running. So you had code that would do one thing at the same time that code was doing a different thing in another quadrant, and it would use the fork method of running the stuff. And the professor said, "I know you've cheated on the code on this if your program runs and continues to run and doesn't break, because printf's not reentrant." And I'm like, "Oh, that's a challenge. I'm going to write a program that actually works." So I used lower level functions to write to the screen that were reentrant and was able to get it to work, and told him basically when the program started, it printed out, "I'm using functions that are reentrant. This program should not crash." And he came back to me later and said something like, "Show off." I don't know. Because they were focused on mathematics more than the computer programming. So, but it was fun, going from one university with one focus to another. I think it made me a better programmer. The one thing I lamented was that I didn't take some business classes too, because I majored in computer science and minored in mathematics. Because you're taking most of the math anyway, why not? Well, I got out of college, my first job, I had to talk to accountants on how to do back-end food costing for, restaurants and stuff. And I didn't understand anything about accounting they had a hard time explaining to me what they were looking for. I had a hard time understanding. They didn't understand me when I was talking about stuff. So I think if I had gotten a master's, I wanted to go into artificial intelligence and genetic algorithms and things like that for masters. And I would have been better off probably if I had done an MBA or something. But whatever. Oh, you ask engineers about big O notation? You know, I would be hard pressed to discuss it much because nobody ever asked me to do anything like that. I'm an average programmer. I'm not, the world's gift to programming by any means. I'm a forms over data, data over forms kind of a programmer. Most of the stuff I've done across my career has to do with, generating reports and, the usual business class application stuff. There's only been a couple of times when I got to do any really cool programming. I managed to get use an algorithm for simulated annealing of metal in a payroll program once because I needed to know what the output of two dependent functions were. So you had to search for local maximums. And you could use Monte Carlo. There's a couple of different ways you could do algorithms. So for payroll processing, this thing made educated guesses at what the maximum was because they had payrolls that said, if it's Tuesday and it's raining, you pay third shift premium unless the regular premium for getting wet while you're working, it pays higher or something like that. And the payroll clerks would just say, I know which one to use. And I'm like, how do you know? I just know. They couldn't give me an algorithm, so I'm like, great, I'll just write something that figures both out. And it would search for local maxima a certain number of iterations before it would give up and just, say human intervention necessary or something like that. Program took forever to run. I think they ended up throwing it out eventually because nobody wanted a program that was guessing how to pay people. Anyway, it was creative. I had fun writing it. What else we got in the chat? Do you, Chris, do you also ask them to whiteboard? Because I've done that before with programmers and they hate it. But, and I know there's some different thoughts about doing this, but I just tell them pseudocode. Just throw up how you would approach solving the problem. I don't really want to see perfect syntax or anything. I'm just asking you to explain to me how you would solve a problem. And sometimes I'll let them pick the problem, to do it. I don't interview software development people anymore. I manage business analysts. But I tell you what, if they can't analyze a problem, that's not the job for them, right? So, my programming experience consists of HyperCard and now live code. Yeah, I've kind of looked at live code, but I'm too much into HyperCard. And then, C programming, it would be useful for HyperCard if you're going to do XCMDs or extend HyperCard, but I've never gone there either. I'm hoping someday to be able to bring those both together. HyperCard, C, C#, C++, Java. Ooh, the Java thing. I avoided Java. I did C#. I did VB.net, ASP.net. So I did some web development. I did some development in PHP, but I couldn't convince our consulting company to use it. And I'm like, it's open, it's free. We can, and they're like, no, Microsoft Stack, that's the only thing we do. Yeah, an MBA is an interesting one. I got one and didn't really utilize it for a few years. Yeah, I'm thinking, if I weren't nearly 60 and I went back to college, I might do an MBA, but at this point in my career, there's no point. Yeah, I've been on and off managing. I was working for a consulting company and was made an offhand comment about why don't we have interns. So they told me to set up the program for it. So I managed a bunch of interns. That was earlier in my career, and then you know the last 5 years I've been working as a manager, but it's for the government, and that's a totally different animal. And it's taken me almost 5 years to learn how to manage people in that kind of an environment. Because I did start managing database analysts and web administrators first, and I've got some really strong opinions about what a DBA should be, and it was not the way the state does that. Then I moved on to managing a project for our customer, one of the agencies, that is going to take about 7 years to do, and it's with an external vendor, but I helped manage the data migration part of it. That was very exhausting. And then I was asked to manage the BAs because in our agency, the BAs was kind of the place you went if there wasn't any other work for you. So it was kind of a mismatch of people that don't really know how to do requirements capture. And I'm trying to set standards for them and train them how to do that. Yeah. You do ask them to whiteboard with pseudocode. Yep. Namely because it is informative, but it tells you more about how good of a presenter they are and how well they communicate with a client, I think, than it does about how they program. I interviewed once for a job to do web development using, I don't even remember what framework it was. It was one that I didn't really have a lot of experience with. And they sat me down in a room with 15 people on a computer projecting on a screen and asked me to do development right there. For somebody that, if you're the type of programmer that likes to work by yourself, that's very intimidating. And I didn't get the job, and it's fine. I'm sure they found somebody younger and smarter and faster and with more experience in that framework than I had. But it was quite an experience. I would never put someone through that for an interview. I don't need to for where I'm at. Yeah, I don't know anybody that really loves Java. It's sort of like COBOL. You can make a lot of money at it, even now. But does anyone really love it? But there's an awful lot of code in it. Okay, can this code order my groceries? No. It cannot. J. And no, I'm not going to write code to order your groceries. We could write a hypercard stack that would order your groceries, and it could also talk over the internet, or the network anyway. But I doubt very much it would be able to interface with any of the online ordering stuff. It could definitely print out a shopping list for you. Maybe even email it. So, okay. Where was I? I was gonna... Okay, I added this. I need to save it. Let's compile this thing. cc fahr.c minus o fahr. Oh, I have a syntax error. Line 9. Great. So, old school. I don't know the command for going to a particular line. So I'm going to do the old school 1, 2, 3, 4, 5, 6, 7, 8. Oh, yeah, it's really obvious. I could have just looked at it. I didn't have to count. There we go. So I want the up arrow so I can get to the prior command. Is there history? Oh, there is a history command. I don't know how to use it from here. I can't remember. Do you do history and then the line number? Oh, what the heck? Let's try it. 38? No. I'm not going to man the page either. See all my typos? I got to edit, do something so the shell will recognize a delete. Okay. The :9. Oh, to get to the, yeah. I'm vaguely remembering. Hey! Maybe you should be doing this presentation, not me. It was 38. I recognize which number to put in. So, you got it. Thank you. I appreciate that. Anyway. There's our table of temperatures. Exciting, isn't it? Could use the tab character in between to better format it. Right? Yeah, that's because you can correct all my mistakes. But I could have just planned all this out and live streamed a scripted thing, but it's more fun this way. So let's put a tab character in here. Oh, helps if you hit insert. Oh, I messed it all up. Hit the insert. Now we're in the insert mode. And that's the wrong slash, Eric. And I'm messing it up even more. Insert. T. Escape. Move over a character. X. There. I think it's T for tab, isn't it? Time to get temperature from user with scanf and deal with that only. Yeah, maybe. You're jumping ahead of chapter. You're asking for input from the user. I'm probably going to have to end the stream here pretty soon anyway. Let's try this. So, should be able to do, oh, not history. Pound 38 still, right? Oh, that's right. 38. Okay. Look at that. It's a beautiful table now. Minority Report gloves and deal with that. Not building that interface. Okay. Let's see what else they got here in this little example from the book. They did move the next 1.4, symbolic constants. They did constants. See, if I just scrolled down, I would have realized that, oh yeah, it doesn't use an equal sign. So we jumped ahead when we did that. And character input and output's next. File copying. They're not using the same example anymore. Line counting, word counting, and then it gets into arrays. So that's enough for this example anyway. So we got our oh yeah, and I made a code subdirectory and I didn't copy the stuff into the code subdirectory. Oh well, I'm not going to mess with that. So I think I'm going to wrap it up here. I am going to start with a installation of AUX from scratch and record it, mostly to double check what I put in the blog post and also to capture some images and things, because I want to make sure that that works exactly the way I described it in there, and there may be some steps that are either vague or need some elaboration. Does the program print each line as it calculates, or does it create a table, the table first? No, it does do it each. Here, let me bring up the code here so we can review that. So this for loop does the calculation. So it sets it to lower. So FAHR, when you first go into the for loop, is 0. It checks, and yeah, add order of execution here. It then executes, I think it does the test statement to make sure that you haven't exceeded. So you could do a for loop where it doesn't do any execution at all. So if we did changed it to FAHR is less or greater than, or how would we do that? If we put lower instead of upper in the loop evaluation statement, it wouldn't execute anything, or it would only execute once, because that lower would be equal to it, and then the next execution it wouldn't. But so it does the first execution of the for loop, so it does the statements that are within the braces for the for loop, does the calculation, and then prints it out. Then it goes to the next iteration. So it executes the increment by step, and then it checks the expression again to see whether or not it should end. It only executes the first statement of the for loop the very first time that you enter it. Does the program print? Okay. Would it run faster by creating the table and then printing it once? No, probably not. For one, you'd have to have storage for the results. So I'd have to have an actual array to store the results, and then you would still end up doing a loop on the array and a printf for each one. So I think you would actually end up with a slower program than what it is now. Not much slower, but it would be slower. It would be faster on the printing, probably. It would sit there and spin and not do any output, and then it would just dump the table probably a little faster on the display. People might wonder what it's doing while it's running. So you'd have to give, human-centered design. You need to give them feedback when the program's running so that they know it's running. You could use the cursors library to, do something like a spinning. What did we used to do? We used to use the slashes and the vertical bar and the dash to do a little spinning thing. Yeah, you could get a little bit of a speed up by storing the division as a constant. Yeah, because it's a ratio, right? So you can move that out of the for loop so it's not calculating it each time. Well, but here as a teaching tool, you want to teach people to think this way. when you're programming in C, especially at this level. And frankly, I think a lot of I haven't been to a computer science class in a long time. Anecdotally, from listening to my eldest daughter, because she had to take some programming classes, she does not like programming at all. And I'm glad that she had them so that she can understand what's going on. And she learned early she didn't want to do that. So she actually works for the state in the same agency I work in, doing customer support. Still has to leverage all that technology information she has. She's an Apple certified tech, so she knows how to although she's probably not certified anymore. She was a couple of years ago. She also originally was going to be a graphic designer. I helped her get an internship where I had been working at one time, and she did a great job doing graphic design work for them. She did, I'm not going to mention the company, but she did posters. I forget what they call them. The info poster kind of a format where you kind of read through it and it tells you some information about something. Can't remember the name for it. It's a particular format for doing those things. Anyway, she did some of those, and she did some animated flash for it and things like that. She used the CS suite to do the development for it. It was both for print media and also online. She did it faster than the contracted person did it. And they loved her. And then when the internship was over, she earned enough money that she bought the full CS6 suite so that she had it available for her. And she said, I don't think I want to do this for a career because I don't like other people telling me how to do art. And I said, that's why it's a job. And if you don't want to do that for a job, then don't. So that was useful for her to have that experience. Otherwise, she would have got a 4-year degree in graphic design and stuff and hated her work, But it is good to teach this kind of low-level logic and how to think about optimization and stuff. Loop unrolling would be another optimization. I'm not familiar with the phrase. Loop unrolling. Is that like breaking down the loop into discrete statements so that you're actually just executing one after the other? Yeah, that would make it faster. Nobody's going to want to write that code. That reminds me of some of the database designs I've seen where they don't use foul third normal form, not even second normal form, and they're like, well, we'll just add another field for that. And I'm like, no, you need to have a child table that handles that, and that way you can have more than 6. You're not just going to add another field for the 7th one. Yeah. But that doesn't mean it isn't a valid way of writing something that would generate code as an optimization. And I've seen that in some compiler situations where the code that's emitted from the compiler, if it recognizes the loop is fixed, it could generate those statements separately and it doesn't actually execute a loop. If you're not going to read the code, why not? I never really got into compiler optimization that much when I was in college. And, they teach you, at least back then, 40 years ago, they taught you computer science so that I could develop my own language and I could optimize it. I could work for Borland, which is what I really wanted to do, to work on languages and all that. And then you get into a business environment and the last thing they want you to do, surprise, is to develop a new programming language and write a compiler. Unless you're working for Google or someone like that, right? I enjoyed programming as a career, but most of the time it was just work, really. When the web took off, I was working for a consulting company and we didn't have any web developers, and this was before ASPX, This is when it was just VB scripting and ASP pages. So I said, I'll do it. And they're like, oh, you know HTML? I'm like, sure. I spent a weekend reading up on it and figured out how to do stuff. It's back in the day when you formatted your pages using tables because CSS didn't exist. And you had to target every single instance of a browser, and the DOM model wasn't very mature, and God, it was a mess. But it was fun, Yeah, compiler writing is a very special kind of thing, but I like reading up on different languages and how they solve problems and how it's different from what I'm used to. Functional languages and functional programming and stuff like that. I'll never have an opportunity to do any of that unless I want to do it as a hobby. And frankly, I've got other hobbies that are more interesting to me than digging into that kind of stuff. But this is kind of archival programming. It's like, oh, I remember what it was like when you had that kind of a syntax error and it took you an hour to figure it out. Or back in the day when you compiled your code, you walked away and you went and got a cup of coffee and maybe you ate a sandwich or you talked to somebody, and then you come back and look at your machine and say, oh, it's still compiling, and then go off and do a little bit more, relaxing and stuff. You could take a mental break while your computer was struggling to compile this big, huge library of code. Today, you hit a button, it's done, or it's interpreted on the fly, or, nobody can take a break anymore on things like that. So the pace is different. And I kind of miss the old days, but I'm also old, so that would explain it. Working in languages like this, in an environment like this, would be so tedious for somebody that's new to it, or rather used to the modern IDEs and the environments for development. Before the internet, we didn't go to /dot. That's an old site anyway. We didn't go. Oh, shoot! What is the site you go to for coding when you don't know anything? You're not sure what to do. Yeah, I can't remember. Anyway, you couldn't go look at things like that. You went to the library or you went to the bookstore and you bought books and things on it, and you went, or you got Dr. Dobbs' journal and went, oh, that's how I could solve that problem. So, anyway. I think I'm going to wrap it up here. I know I could just keep talking about this nostalgia stuff forever, but wife's coming home from shopping soon, and she's going to need help hauling in the groceries, so I don't want to interrupt things in the middle of having to do that. So thanks, everybody, for showing up for my little impromptu live stream. I'm going to play that outro stuff, and I'll see you on the next video. Bye, everybody.